how's it going? It's Andy. And today we're going to go over the chain rule. Now, I was writing this and I got a little bit carried away, so I'm just going to move everything down a little. We're just going to explain it. So what is the chain rule? What is it? Well, let's say we got a composite function, Jesus. So we're going to say, it's f of g of x, right? So, this is going to be like if we actually gave it something, it would look like x squared plus 1 squared. Now, when we take the derivative of this, we need to do a sort of chain. So it's going to be f prime of g of x. That's basically the power rule. But we need to account for how much by that's, or let me reword that because that sounded pretty dumb. We need to account for how much this is changing over time. So we need to do g prime of x multiplied by that. So that's the chain rule. And why do we do it? Well, we need to account for that bit right there. So we need to Jesus, I'm doing it again. We need to account for how much this is changing. Anyway, so now we're just gonna, because I like to prove that I'm right, we're just gonna show you that it works. So let's derive this using the chain rule. So that's just gonna be 2 x squared plus 1. Now we need to find the derivative of this. So that's just gonna be 2x. And now we can multiply this. We get 4x, x squared plus 1 to the first. Now if we just do the power rule, we just get 2x squared plus 1. And initially I thought I was going to do like the limit definition, but I'll show you a problem that creates. You see this messy thing right here? Yeah, I don't want to deal with that, so just take my word for it. If you were to compute this, do x squared plus 2hx plus h squared plus 1 squared minus that thing, then you're going to get the same answer. And without further ado, let's move on to some examples. So we got this one right here. 3x squared plus 2 squared. So again, we just bring that down like a, power rule. 3x squared plus 2 to the first. And now, well, that one times that one, that's 6x. And that one doesn't have a derivative, so because if we do 2 to the 0, 2 or 1 times 2 to the 0, then it's just going to be 1. So there's no derivative for a constant like that. So that's just going to be 12x 3x squared plus 2. Now we got this thing right here. Well, oh God, you got a 10 right there and you got a 3. Well, it's the same process. You just bring the 10 down. 4x to the third minus 2x to the ninth, and now the derivative of this thing. So that's just going to be 12x squared. Bring that down. Subtract 1. 12x squared minus 2x to the first. Bring the 1 down. This is going to be 2. And I'm not really a fan of simplification, so I just leave it like this. If you wanted to factor it out, you'd be wasting your time. We don't really have time for that in calculus. And what about sine? Well, I haven't told you anything about sine yet. Sine looks like that on a graph. And if we were to graph by how much it was changing by, it would actually be cosine. So that looks awful, but that's basically by, that's how much it's changing. And we can see this, like,
here, it's going to change a lot, and, here, it's going to bottom out. So, and here, it's going to start going down pretty fast, and then it's going to slow down a bit, and then it's going to go back up. That's basically that little trick that I showed you. Like, this is the derivative here. That's one way to check your work.
If the derivative curve matches, like, the rate of change, then you've probably got the right answer, or you're getting close. So this, derivative of sine is just cosine of x. But we got a 3x right there. So what do? Well, it's chain rule again. So we need to take out the 3, sine 3x. Or, excuse me, cosine 3x. And that's it. And, cosine. Well, if we draw the graph again.
And I apologize, it's going to look very bad. Alright, so here's cosine, roughly. And, here's sine. There we go, that looks kind of like a 3-year-old did it, but oh well. Now, if we notice one thing, this does not describe the cosine curve. But if we flip it, let's actually see if I can do this. No, that kind of worked. I can rotate it, and just know that if we multiply by -1, so right there, and right there, that models how it changes over time, because here it starts to go down, here it starts to go down, and then, it bottoms out. I guess that is wrong. Oh well, it starts to increase, right around here, and it goes up. So
just know that derivative of cosine is derivative of cosine of x is just negative sine x. So cosine 4x, negative sine 4x, take the 4 out, put it right there, negative 4 sine 4x. That's all I got for you today. Practice the chain rule a bit. It's pretty easy. Just remember that when you got a composite function, like, x squared plus 1, and there's something out here, like, whether it be 3/2 or 2 or 7 or... a billion. Just remember, you gotta take the derivative of this and multiply it out. Otherwise, it's not gonna work. Alright, peace out. I'm Andy. Like and subscribe if you like this. I guess that's kind of an awkward statement.